Hello, welcome to Pit Makerspace's workshop on Grasshopper. Um, this workshop happened synchronously about 2 weeks ago, but I said that I'd record it for a friend of mine. Um, the day after that happened, my laptop broke, and then I fixed it. And then I watched the recording, and it wasn't that good. So we're here with a YouTube video. I'll try and cover just about the same content, and I think it will be a lot more streamlined because that workshop ended up being about 2 hours. I think I could do this in 20 minutes. Okay, let's start off by introducing what Grasshopper is. And in order to do that, we have to start by introducing what Rhino is. So Rhino is an architectural CAD software. It is what you see right in front of me. And Grasshopper is a plugin for that lets us create algorithms to model just about anything. So let's talk about what makes Rhino and Grasshopper really special before we start getting our hands dirty. So if we're to conceptualize CAD software on a spectrum where we have hard engineering CAD software on one end, this is your SolidWorks, your Fusion 360, and artistic CAD software on the other end, this is your Blender. Grasshopper and Rhino sit somewhere in between. They're capable of getting these tolerances and specific dimensions, but they're also capable of some really organic shapes. So when you open when you open Rhino, it'll look something like this. I have to be transparent here. I am really bad at Rhino. I've never taken the time to learn it. I've never needed it. So let's get into Grasshopper. And also, to be transparent, I just upgraded to Rhino 8. This is actually like my third or fourth take of this video. And the last take got ruined because in the middle of it, I got an email saying that my educational license for Grasshopper or Rhino 8 had been approved. So here we are. If you need to download Rhino, you can come to the website rhino3d.com and download here, and there is a full version for 90 days. Pretty sweet free trial. But let's get right into it. It looks like there's a button for Grasshopper right here. I don't know if that's standard. You can also just type Grasshopper into this command line up here. That's about all we need from Rhino, because this will open into a new window. I'm actually gonna, no I'm not. We're gonna maybe jump cut here. Alright, we're back. When you open Grasshopper, it'll look something like this. I recommend throwing Rhino up on the left side of your monitor and Grasshopper on the right. Having a large monitor is pretty useful here. Let's just talk about the way Grasshopper works. Up here, you've got a bunch of tabs, and here is your workspace. So the really cool thing about Grasshopper is your ability to parameterize things, whatever works for you. So I've just grabbed a number slider block. I did this by clicking and clicking again, and you can grab the number slider and change it. Which, seems pretty intuitive, pretty straightforward, not a big deal. These get really cool when you start... Whoa, did that just go away? That was uncool. Okay. These get really cool when you start using them a little bit more aggressively. This is maybe pretty overwhelming. This is something I made quite some time ago. But it's a really good example of the way that parametrized design can echo into our creations in Grasshopper. So here you can see I have Y coordinate, Z coordinate, and X coordinate, and these sliders, these top two range from from 0.1 to 1, and the bottom one goes from 2 to 5. So actually, you could just see it there as I was changing them. Let's take a look at... I'll zoom in on this view, and we'll keep this one how it is. Actually, we'll zoom in on all of them. So as I change this y coordinate, you can see that the triangle grows wider. So let's be clear about the functionality of Rhino and Grasshopper. So this shape, it does not exist in Rhino right now. It is almost like a hologram, and I can change the way that it draws by changing this. So if you're trying to interact with what you've created in Grasshopper using Rhino, don't do that. We'll get to that in a bit. So all that said, you can see the way that my changing of this slider changes the dimensions of the part, and these live update so I can see different iterations of this part and decide on what I like. I've also created a drop down here to change the cross-section type for the arm. Oh, I forgot to tell you what this is. So it kind of looks like a silly looking spoon. You wouldn't be too far off in that guess. This is a catapult arm meant to be printed out of TPU, so that kindergarten students, kindergarten through 5th grade students, can have some part in their design of a 3D printed part. So my vision for this was that students could have access to these 4 parameters, right? They can choose a round, triangular, or square cross-section for the arm of their catapult and change these parameters, make it wider, taller, or shorter and longer. And my vision here was that students could go through the scientific process of deciding what arm type provides the best launch for a ping pong ball. So students don't have to actually design this part, but it is a great way for them to conceptualize the idea that changing numbers can change the way that something looks. Unless you change this number on a round cross section, because I have this set to the radius, and if you change, all you can change on a circle is the radius. Cool. All right, I had a bit of a mix up there. We're going to open up another part, or another script. It's always been very unclear to me what I should be calling Grasshopper files. Sometimes I call them scripts, sometimes I call them other things. Don't get too wrapped up in it, doesn't matter. Anyway, this script, guess we're running with that now, requires the import of a mesh. You can see this up here. You can see that it's orange. It's got a little bubble over it. It says a reference mesh could not be found in the Rhino document. Let's fix that. So if I go into Rhino and open and go to here, we can import this frog mesh. This frog mesh is from Thingiverse, nothing special about it, just any old mesh. So what I'm doing here is I'm left clicking the frog mesh. You can see that it's selected because it's yellow. A pretty offensive yellow, honestly. It's really high saturation. And I'm right clicking on my mesh block, and I hit set one mesh. And now it's going to lag a little bit, and you can't see it that well here, so let's go ahead and hide this. And so you can see that our frog mesh has been reconstructed out of what are called voxels, the 3D equivalent of pixels. This is one of my favorite scripts I've ever made because it has compatibility with any mesh. And I think that's something that's really special about Grasshopper. We can create workflows that are generic and they can be applied to any part that we want to work with. That's something that I get really excited about, and you should too. It's a bit of the future of design for additive manufacturing. Anyway, that's a bit of a tangent, and a whole other workshop, perhaps. So, let's look at, oh no, this one. This one as well. So, give me 1 second to make this a little bit prettier. Huh. There we go. All right. This one is a lampshade, and is, well, not is. This one is a lampshade, which is what we will be making in this workshop in a little bit. So the cool thing about lampshades, you may have noticed that this is titled Vase Maker. The cool thing about lampshades and vases is they are the same thing. If you take a lampshade and you flip it upside down and you put a hole in it, it's a vase. This lampshade utilizes polar coordinate plotting in order to draw a really interestingly shaped curve, create a bunch of them, and then create a loft about those. And we'll be following the same high-level structure for our lampshade later. But the really exciting thing about this is if we come in here and change, nope, not that one, change this number, we can change the period of the wave that I've overlaid on a sphere. So you can see that if I take this down to 1, we just have a sphere, a truncated one at that. And as we increase this number, we increase the number of ripples on the sphere. We can create some really, really interesting geometries using this. This is something I get pretty excited about, and as far as I've seen, some other people get pretty excited about it as well. You can create some really cool shapes, and seeing it change live is really exciting. Let's get our hands dirty with something like this. I'm going to do the same thing that I just did to the last one. No, not that. Right there, cool. So we're going to be making something kind of similar to this. And my hope is that by the end of this, you know exactly what is going on here. I start majorly yapping here, so we're going to jump cut to the next section. Graph. No, we're just going to jump into it. All right. Hopefully I have jump cut to this. We are going to start by creating a range. So let's talk about how we get blocks that we want. Generally, I like to double click. It brings up the search box and just type in whatever block we're looking for. So we're going to start off looking for a domain. Nope, not that one. We're going to look for construct domain. This one. So let's mouse over construct domain and we'll read what it does. It says it creates a numeric domain from 2 numeric extremes. So we start with domain start A and end at domain B. And our output is a 0 to 1 domain. So as you just saw there, you can mouse over a block to see what it does, mouse over the inputs to see what they are, and mouse over your output to see what it is. On its own, the domain isn't a very powerful block, but it's a great building block. After that, we're going to grab a range. So by wiring our domain into the domain input of our range, we can output a range from 0 to 1. And just so we're clear, the range block creates a range of numbers. So the range block takes a domain and a number of steps. In this case, our number of steps is defined as 10. So we've taken a number line from 0 to 1 and we've sliced it up 10 times. So we have 11 total values. Excuse me. After that, we're going to use one of my favorite blocks of all time, the graph mapper. So the graph mapper doesn't do anything. No, I'm just playing. If you right click on the graph mapper, you can get to graph types, and my favorite has to be the Bezier. By dragging these points around, you can radically change the shape of this curve. And so all the graph mapper does, and you can see this from these red lines here, is take a set of X input values, and then it has a function internalized to it, which we define using the graph mapping properties. And it returns the outputs of that function. So, we're taking an x value, which is indicated by each of these red lines, and we're returning the y value at the intersections of those. So you can see one here, one here, one here, one here. And this one doesn't have a super friendly mousing. Oh, you can see the output here. So you can see our outputs range from 0 to 1. But that doesn't mean a ton to us. Let's graph them. So here we're going to call back to Calc 2. Sorry for those of us who have Calc 2 related trauma. So I've just grabbed point cylindrical. So this creates a point from a cylindrical angle, radius, and elevation. And when you create this point cylindrical, it creates this red plane here. This bothers me infinitely. So I always take this XY plane, wire it into here, and I turn off preview. So to do that, you can just right click a block and hit preview, or you could draw a box around it and use middle mouse button and hit this dude with a blindfold on. So now our red plane is gone and I am happy. I should also draw attention to the fact that as data flows from one point to another, the wire type indicates what type of data is flowing. So data can be a single value as indicated by a single line. It can be a list of values as shown by a double line, or it can be a tree of values as shown by a dotted line. Don't worry about trees. They are such a pain in the neck to handle. I really would recommend that you don't mess with them for quite some time. Also, just then I aligned these blocks. If you draw a box around them, you get these little alignment tools. They're pretty sweet. This one on the left will evenly space them. It's pretty sweet. Yeah, Rhino is filled with little tidbits that are fantastic. I would add, if you hold Control and Alt, you'll see that my cursor just changed to like a little information icon, and I click on a block. It pops up with these red arrows to show you exactly where that block is from. And you can use this to find similar blocks. So maybe I don't want range, but I want a series. I've never used the series block. I don't know what it does. Looks like it creates a series. Who would have guessed? Don't worry about that. So let's visualize this data. So our inputs for our point cylindrical function are base plane, angle, radius, and elevation. So the base plane is the center point for which we are graphing our points. So all planes have origins, and they have angles associated with them. This plane is world XY, so it is just flat, and it uses our world origin, which is 0, 0, 0. So that's nice. We can just center everything. Let's try wiring the elevation into that. So you can see that we have just a bunch of points stacked on top of each other. We can mouse over this. It says this component ran 11 times. We have graphed a bunch of points at at angle 0, radius 1, and our list of elevations. However, if we take our range and wire this into radius, we can see that we've just created a 2D analog to our graph mapper. And as we change this graph mapper, these points will change their position. So congratulations, you've created your first parametrized 3D model. You might argue this is a 2D model. I don't care. After this, we're going to use a interpolate curve function. So interpolate curve takes vertices, degree, periodic, which is just a Boolean true or false, and not style. I'm not concerned with these bottom three. I've never used them. But if we wire our points into our vertices, you can see now that we have a line, and when we click on that, it gets highlighted in green. Very useful. So we've created one line. Let's move on to a polar array. And again, we have that really annoying plane back, so we're just going to wire our same invisible plane into that. And we're going to, let's look at the outputs of our interpolate curve. We have curve, length, and domain. You may have guessed that we don't care about the length and the domain because we're not running any calculations on this curve. Let's just feed this curve directly into the geometry of our polar array. So this is pretty sweet, right? We've got a bunch of lines coming out of a single point. You might be starting to see how this could look like a lampshade. Maybe if you flip this upside down, kind of like a banana peel shape, put a light inside, that'd be a pretty sweet lampshade, actually. Let's make it a little bit prettier on our end, just so that we can process what's going on. If we draw a box around these, and you'll notice I always start my boxes at the top right and draw down. If I started at the bottom left and drew up, I'd only select things that I drew the box fully around. We don't need to be doing that. So again, I'm using middle mouse button to turn off the visibility of those points. And now we have a sweet view of our lines. So when we talk Grasshopper, we want to talk about data types. This is really core to the way Grasshopper functions. You know, the data type output of our domain block is a domain, not very useful. Range returns a list of numbers. Point cylindrical returns a list of points. And we've turned those points into a line, turned that line into a bunch more lines. So you could see how using a bunch of lines can't really make us a 3D shape until we do a little bit more work with it. So let's move on to lofting these lines. So again, I forgot to tell you what polar array does. It creates a polar array of geometry. You would never guess. So it's the same as looking at our center point, creating a copy of it, rotating, creating another one, and doing that all around. Very similar to the circular pattern tool in SolidWorks if you've ever used that. Now a loft creates a lofted surface through a set of section curves. So we're going to create a surface that runs through each of these curves. So let's do that. Okay. So you can see that we've got a little issue here. It is missing a slice of the pie. Let's look at our other input of our loft block. It is loft options. So whenever we have an input block like this and we don't feel like messing with wiring up its values, we can right click it and come down here. Oh, and that's popping up on my second monitor. Let's do this. We can come into here and we can look at the loft options. So we have a checkbox for closed loft, align sections. We have a couple options for how we do our loft, and a couple options. I'm actually not sure what these are. I'll spoil the fun for you and tell you that we need a closed loft, and that will complete our block. So when we're talking closed loft versus open loft, an open loft runs through all of the points, all of the lines as if creating a single sweep, like it's a one-way street. Closed loft acknowledges that it's meant to be a full loop. So then we have our shape. And again, this is still fully parametrized. We can move these points around and change this into a completely different shape. Maybe we want it really pointy. Or maybe we want it really round. Who knows? So, I mean, right, we have something that looks pretty much like a lampshade, but it's not that exciting. And maybe not something that you'd be incapable of creating on SolidWorks. bear with me. We're going to start to get a little bit crazy here. So if we use a block called scale NU, so this is a non-uniform scale block. You could consider the way that a normal scale would work. The X, Y, and Z components would scale the same amount at the same time. The non-uniform scale allows us to define individual values for each of those scaling components. So, and let's get rid of the red plane that bothers me so much. Let's introduce a slider. When we want to put a slider in, we could definitely just type slider, but that's boring and inefficient. If we simply type in numbers, and you'll notice that I'm using 0.0 here. I'll show you why in a second. If we type in numbers and a less than sign, we can create our slider that way. So you'll notice that since I put in 0.0, I can now slide this along the tenths. And let's actually give this some geometry to scale. How about our curves? Nope. How about our list of curves? So you can see I have it, and this will be easier to see if we toggle the visibility here. So you can see now, as I change this slider, I move this intersection, not intersection, in and out. So with that, we've got an inner set of curves and an outer set of curves, but we're not quite at what we want. I can't really describe what's going on, what we're planning to do without showing you, so I'm just going to ask that you bear with me. We're going to grab a rotate block. The rotate block takes geometry, angle, and plane. So we're going to put the geometry of our scale non-uniform into our rotate block. And this is starting to get busy again, so let's toggle the visibility of our scale non-uniform. And let's right-click our angle, set it to degrees for ease of, for simplicity's sake. And let's create a slider from 0 to 30. So now we can spin this. And let's see, there's 10 sections. I believe that makes our midpoint 18 degrees. And that looks about good. So now we're going to get into the reason that I couldn't explain what we were going to do. We're going to use a block called a weave. So a weave block will take two sets of input data and then a pattern as a list, and output one set of data that weaves the two lists using that pattern. The default list is 0, 1. That's to say, if we give it our set of outer curves and our set of inner curves, we get out one list that has all the curves on it. Now, the cool thing about the way that we combine these two lists is the order. So again, I'm just going to create a number slider, and you don't have to follow along with this part if you don't want to. But this is a really great way, in my opinion, to debug what's going on in the order of a list. So I have list item here, and I have the list that I want to inspect, and then I have a simple slider wired into the index of the list. So as I vary this slider, we can see how we're going through the order of the items on the list. And you can see that we go from one inner curve to one of the outer curves. And we just follow that pattern, and we swing around like that. So now, if we wire this weave into our loft, let's turn the visibility back on, and we've got a pretty cool shape. Safe to say that this is not something that would be taught in a sophomore level mechanical engineering class on SolidWorks. These blocks are not essential anymore, and these are making it busy. If you made this in your sophomore mechanical engineering SolidWorks course, I personally would be very impressed. Cue somebody in the comments. The comments? What am I, famous? Cue somebody emailing me, BJ, actually, it's really easy to make this in SolidWorks. Just use the polar or the circular pattern tool. I don't believe you. Sorry. Okay, so we have something looking pretty lampshade-like. Let's experiment with changing the shape again. Whoa, don't double-click on your graph mapper. It gets into something that is way more complicated than it's worth. Not really. You can change your input domain and your output domain. Your domain and your range, if you will. It's a function. And you can change these points more precisely. But I prefer to just use it this way. So, I mean, our shape looks pretty cool, but we haven't even touched the angle of our cylindrical coordinates. Let's do it. So if I grab this block and then I hold Alt, I can create a duplicate of it with the same input wired to it. And let's change this graph type maybe to a sine wave. So with the sine wave, we can grab this piece and set it to whatever we want and set the output right there. All right, so that looks pretty sweet, kind of crazy, but I don't think it'll 3D print. The vision here is to 3D print these eventually, if that was unclear. Actually, it certainly was. I never said that we were 3D printing this. You can 3D print lampshades. It's really awesome. I can't wait for you to try it. So let's run with something like that. All right, so in terms of 3D printing, we run into a major issue down here because our curve angle is too shallow to 3D print. We need a nice flat bottom. So this gets into a pretty niche way that we can solve this problem. But I think it's a really awesome learning experience. I did this live during the workshop when we were running it. And this is part of what made the workshop so bad. So I believe okay, I'll be back. We're gonna jump cut. I gotta figure this out again. All right, I thought about it and we're back. So we're gonna grab a smaller than block, and we're gonna take these values and we are going to ask, what does this run? Does it run A less than B? I mean, we'll find out. Yes, it does. Okay. So let's take all of our values, maybe less than 0.15, it looks like, and we'll floor them. That's to say we will set them to 0. So let's, again, I right-clicked on B here to set this number, and I set it to 0.15, and now we have a list of trues and falses. So now in our sets tab, we have, I believe it is dispatch, and we're going to dispatch this pattern using this one. So now all of our values below 0.15 are on our A list, and all of our values above 0.15 are on our B list. And this is what starts to make Grasshopper scripts look really, really ugly. You end up with these niche problems that you need to solve, and you create some solution, but it ends up looking really ugly. So each individual part might make sense, but altogether it gets really overwhelming. We're going to dispatch these lists into 2, and then we are going to combine them, which actually we don't even need to do. So let's take, so here I'm doing asterisk 0. This will create a multiplication block and set B to 0. And now we can wire A to A. So these are all of our less than 0.15 points. And we have B right here, all of our greater than 0.15 points. And we can wire our elevation. That's what we're trying to solve. we can put this into here, and this is going to get mad at us because we've given it the wrong number of points. But if we grab this and we hold shift, you can see that my cursor has changed, and we can drag this to here, and now it's flat down here and then rapidly curves up. I think that looks pretty good. So let's talk a little bit more about what you can customize about these. Our polar array, we haven't even touched the number of elements. I don't recommend changing the angle. We definitely want a full circle. However, if we change the number of elements, let's create a slider from 0 to 20 maybe. We can, it gets mad at us with 0, kind of obviously maybe. If we set it to 5, it's a much simpler looking lampshade, and we can change this angle to create some crazy curves on it. And we can play with these until this looks like what we want. And maybe we're kind of bored by this, so let's come in here and make it maybe, I don't even know what this one is. Let's not make it that one. Let's make it a Gaussian. Run it out here and do something like that. You know, we're getting into the bowl territory rather than the lampshade territory, but you get the idea. You really have a lot of power over this lampshade to do whatever you want. Oh, this is fun. You can see where things cut between above 0.15 and below. That's nice. Anyway, we can vary this however we want. Maybe we want a really complex lampshade. Maybe we want one that's really simple, like 3. Actually, I think that looks kind of cool. And this angle, maybe it's not big enough for us. Maybe we want a different one. And maybe we want to change this scale. So maybe we've decided that we don't even like the bounds of this. If we double click our angle, brings up this dialog box, which I consider pretty ugly. Let's set this max to 45 and set this scale down to 0.4. Yeah, that's pretty cool. So we encounter a larger problem. Our loft gives us an untrimmed surface. So let's just run this into Cura and see what happens. Maybe you're planning on printing this in Vos mode and you'll cut the hole for the lamp yourself. So in order to get something like this into Cura, you can right click your output and hit, actually, let's see this. I think they just added a new feature. Yeah, they did. This is new to Rhino 8. Really excited about it. Check it out. If we wire our output of our loft into this, what is this called? Content cache? I don't like that. They should call it bake because it's a little egg and it means that you're baking it. So let's hide all of that and let's hit this update button, and this brings it into Rhino. So now when we click on it, you can see one open surface added to selection. So here is our shape. We can select this and we can type in export, and I'm just gonna throw it in Grasshopper Workshop. Let's call it Lampshade 1, and we want this as an, where are you sucker? An STL. Lampshade1.stl. Cool. And it asks us the tolerance. I don't care. Binary or ASCII. I've been told that you should pretty much never use ASCII. It is like an antiquated form of meshing that isn't really useful for 3D printing. It might be useful for like view factor things. I don't know. Email NPH. Oh, I forget his email. Natan Herzog about this one. And let's go ahead and open Cura. Oh, okay. I put it on my other browser. Okay, jump cut. I didn't mean browser. I meant Okay, we're back. I've reviewed the last section of video. Depending on where I choose to jump cut this, let's clarify. I meant drive, not browser. Turns out I did not even have Cura downloaded. I think I deleted it to make room for Starfield, which didn't even run on my computer. So anyway, Cura, freshly downloaded, but somehow still knows that I really like the artillery sidewinder. whatever. That's not cool. Let's head into our Grasshopper Workshop folder, and open this up. So this is something pretty awesome. I don't know if you've probably never seen this before because you don't get it unless you're working with surfaces. But yeah, because this is an open surface, an open mesh, I'm in Grasshopper mode. Kira does not know what is going on here. It's very confused by it. But you could print this anyway. You could tell it, I don't care what you have to say. Oh, nuts. That doesn't look that good. Let's do something about that. If we grab this and we drop it a little bit into the bed, we're getting there. Drop it a little bit more into the bed. Cool. It's got some red areas. I think they'll be fine, in my professional opinion. In your Cura settings, this is awesome if you don't know it, by the way. There's like this isn't called a meatball menu. Hamburger menu, maybe? You can change how much is shown here. Keep that on all. It's awesome. It'll overwhelm you really easily. If you come down to special modes, I think, right, you have this spiralized outer contour. This is also known as vase mode. So let's check that. And we're going to slice it. And so even though we have this open mesh, it actually doesn't care in the preview. You can see it gets a little funky up here at the top. Like these lines definitely will not work right. It doesn't matter. You could take a little bit off the top if you want to. You know, play barber on your print. Yeah. And you could cut the hole in that yourself. And that would be a lampshade. And you got to trust me on this. Like obviously you can't see it here. These lampshades look sweet. It also gets really interesting when you have like a low resolution mesh like this. Like you see these individual triangles here. The light hits them so beautifully. You gotta try it. You gotta try it. Anyway, let's talk making an actually good part in Rhino. So first things first, we're gonna need to put a hole in this. That's what we're gonna do first. In order to do that, we're going to create a cylinder. I believe we can just call it a cylinder. And let's reduce the radius to, oh, you know what? No, first we're going to scale this up. And let's scale it to be much bigger. So I grabbed a scale block, wired our loft to the geometry. You can set a center point. I don't care. You can also set a factor. So I'm going to right click that and let's set this to 2. Let's make it really big. Awesome. I think actually, okay, so 2 is actually not very big. I think a pretty standard, whoa. The red plane is back. Get rid of it. In this case, B is base plane. I think a pretty standard size for these is like 1.5 inches. So I guess that makes our radius 0.625. Is that right? 5/8. Not 1.5 inches, 1.25 inches. You just gotta trust me when I say that. So let's make this much larger. Maybe not much larger. Let's set it to 4. Sure. Okay, cool. Our cylinder currently will not work. Because it doesn't actually intersect this bottom plate. Perhaps it does, but in Grasshopper terms, it does not. The issue actually becomes the fact that our base plane is in the wrong spot. So we're going to create an offset plane. Also, it is like very arbitrary how I decide to grab blocks. Sometimes I grab them from up here. Sometimes I type them in. Sorry. We're going to set the offset on this to -1. Does not really matter what we set it to. But now you can see that we've created another plane that is below the surface of our shape. So if we wire this in for the base plane and turn off the preview because it's ugly, and then we set the length on this up to maybe 2, now we have a cylinder that intersects the bottom of our vase. So we're going to cap holes. And so this is another important understanding of data types. This is an untrimmed surface. If we plug it into our cap holes algorithm, I call it an algorithm because sometimes it gives you an error that says the hole capping algorithm failed or something. So I think that's awesome. Anyway, the data type here becomes a closed BREP, which is short for boundary representation. And so that is just it telling us that this is a solid, which is awesome. So now we're going to grab an intersection block, and I believe we want... I'm going to get this wrong probably a couple times. Don't be surprised if I jump cut this. Yeah! Alright, so now we have the hole in it, and you could run through the process that I outlined before, and you could 3D print this, even though Kira will get really mad at you. Because vases don't need thickness. Lampshades don't need thickness. Now, suppose you wanted thickness on this, which... I'd be wagging my fist at you. I'm going to be real with you. My recommendation is to do it on the Rhino side. Adding thickness in Grasshopper is really difficult. Maybe I'll add like a hypercut here of me trying to add thickness to this, and I think it'll be really funny to do that. Okay. Oh, okay. Yeah, so it's like doable. It's just not worth it. So yeah, what I to talk you through this like very briefly because it's not really worth it. I took the volume of the shape, which has a return of the centroid of it. I scaled it down to 90%. I capped both of the shapes, and then I moved it up a little tiny bit, and then that's what this is, the move up a little tiny bit, and then I intersected the two shapes to create a solid shape. Don't do this. It's just not worth it. It takes forever, and it's like not efficient, and it's not robust. Instead of doing all that, we have this shape, right? And we can just select it in Grasshopper and use offset surface. Now, and let's see, let's do both sides, and let's set the distance to, I don't know, 0.1. And let's just hit enter. Yeah, now you have a closed poly surface, and we can export that as lampshade number 2.stl. Yeah. Oh, it's NPH 17. I looked it up while I was in between one of these cuts. Email him about that. He'll probably get excited. I'll get really, really happy to hear that somebody cares about meshes as much as him. Anyway, I've imported it into Kira. It's really small. That sucks. Oh crap. This probably imported in millimeters. I'm going to scale it up to 2540%. That's the conversion rate between millimeters and centimeters. And now it has thickness. Again, but some of this isn't touching the build plate. Let's drop it down a little bit. Perfect. And we could print this. And, you know, there's some highlighted red areas. I think they'd be chill. I'm actually not sure. These ones actually definitely wouldn't be chill. You know, maybe you print it with supports. I'm kind of anti-supports on principle, but, you know, it is what it is. But yeah, I think that's the bread and butter of what I wanted to show you guys. Remember when I said this was going to be 20 minutes? That's pretty embarrassing. Anyway, it's half price burger night at Stacked. Drew and I are going to go get burgers. Thank you and good night.